Hi students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter called as network analysis. Let's see this. We're doing question number 4 on page 373. I'll write the sum down. Events 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6, 5 to 6, 6 to 7. Right? Time in days. Okay, time in weeks they've given you. They've given you 3 types of times: optimistic time, most likely time, and pessimistic time. 2 to 14, 2, 8, 14, 4, 4, 16, 2, 2, 2, 4, 10, 28, 4, 10, 16, 6, 12, 30, 2, 4, 6. Right? Now let's see this. Now, the fact that they've given you 3 times, that means this has to be PERT analysis. Now, if it is PERT analysis, the first thing that you need to do is make a time estimate table. So the first thing that you will do is make a time estimate table, right? Let's see this. Event 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6, 5 to 6, 6 to 7. We'll call this as event A, B, C activity, D, E, F and G, right? Estimated time. Estimated time TE is given by the formula optimistic time plus 4 times most likely times plus pessimistic time divided by 6, right? For event A, it is going to be 2 plus 4 into 2 plus 14 divided by 6, right? So when you work this out, this should come out to be 4. Next, you will have 2 plus 4 into 8 plus 14 divided by 6. When you work this out, this will come out to be 8 weeks. Next, you will have 4 plus 4 into 4 plus 16 upon 6. Right? When you work this out, this will come to 6. Next, you have 2 plus 4 into 2 plus 2 upon 6. Right? When you work this out, this will come out to be 2. Next, you have 4 plus 4 into 10 plus 28 divided by 6. This will come out to be 12. Next, you're going to have 3, 5, 4, 6. 4, 6 is 4 plus 4 into 10 plus 16 divided by 6. So when you work this out, this will come to 10. Then 5, 6. 5, 6 is going to be equal to 6 plus 4 into 12 plus 30 divided by 6. When you work this out, this will come to 14. Next, this is 2 plus 4 into 4 plus 6 upon 6. This will come out to be 4. So now I've got my estimated time. Once I get my estimated time, the next thing that I need to find out is variance. I need to find out variance. How do I get variance? Variance is b minus a the whole square upon 36, right? So now this is going to be 14 minus 2, 12, 144 upon 36. Next, this is 14 minus 2, 12, so 144 upon 36. Next, 16 minus 4, 12, 144 upon 36. Next, 2 minus 2, 0 upon 36. 28 minus 4, 24. 24 is 576 upon 36. Next, 16 minus 4, 12, 144 upon 36. Next, 30 minus 6, 24, 576 upon 36. And last is 6 minus 2, 4, 16 upon 36. So I have my time estimate table made. The second thing that I need to do is now make network diagram. Right? Now you have from 1 you have 2 and 3. From 1 you have 2 and from 1 you have 3. 1 to 2 is activity A, activity B. This is 4 weeks and this is 8 weeks. Right? Then from 1 you also have 4. Okay, so we'll do one thing. We'll make 1, 2, 3 and 1 to 4. So this is going to be 1 to 3. We'll call this as activity B, which is 8 hours. And 1 to 4 activity C, which is going to be 6 hours. Right? Next, you have D, E, F, G, H. Okay. Now 2, from 2 you have to 5. From 2 to 5. 2 to 5 is activity D, which is 2 hours. Then from 3 also you have 5. From 3 to 5 is activity E, which is 12 hours. Then from 4 you have 6. From 4 you have 6, which is activity F, 10 hours. From 5 you have 6, which is activity G, which is 14 hours. And from 6 you have 7, which is activity H, which is 4 hours. So that will be my network diagram. Once I have the network diagram, now let's find out the path. I have to go from 1 to 7. Now the various paths I have is A, B, G, H. The other path I have is B, E, G, H. The third path I have is C, F, H. Right? A, D, G, H, B, E, G, H and C, F, H. So these are the 3 paths I have. Now let's see this duration. This is going to be 4 plus 2 plus 14 plus 4. 14, 16, 20, 24 weeks. Next, this is going to be 8 plus 12 plus 14 plus 4. 20, 34. 34 plus 4, 38 weeks. Right? And the next is going to be 6 plus 10 plus 4. 20 weeks. Right? So I have got my duration done. The next thing that I need to do is, guys, so I can therefore say that my critical path is going to be BEGH, normal project completion time. Normal project completion time is 38 weeks. Variance is going to be, now my critical path is BEGH. So for B it is 144 upon 36. E is 576 upon 36. BEG 576 upon 36. H 16 upon 36. Right? So when I add all of that, this is 1312 upon 36, which works out to 36.44. Once I have variance, then I can find out standard deviation. Standard deviation is nothing but square root of variance. This is going to be square root of 36.44, which is going to be nothing but
6.036.
6.036, which I'm going to take it as 6.04. Okay, now once this is done, let's see what are the questions that they've asked me. They've said that we made the PERT network. What project completion will have 90% confidence of completion? 90% confidence of completion, right? If I want 90% confidence of completion, first let me draw my bell curve, guys. Let's see my bell curve. This is my bell curve. This is 50% area. This area is 0.5, and I want 90% area. This area will have to be 0.4. See, probability is 90%. 90% is nothing but 90 upon 100, which is going to be nothing but 0.9. That is the probability that I need. The probability of project completion should be 90%, right? So I can therefore say that the required area is going to be 90 minus 0.5, which is 0.4. Now people, please understand the difference. In your normal distribution table, you have some numbers here, you have some numbers here, and you have a whole lot of numbers in the center. When they say you want confidence, you want to find out area, you look at these numbers and get this. And if normal distribution is given, you look at the numbers which are in the columns and get the area. This will give you your normal distribution variable Z, and this is area. So when area is given to you, you have to look at this part of the table. When normal distribution variable is given to you, you look at this part of the table. Let's try to find this out. I can therefore say that Z will correspond to 0.4. What's the closest I can get to 0.4? Is 0.4015. That's the closest I can get to 0.4, which is going to be 1.29, right? This should come to 1.29. That's the closest I could get to 0.4, right? Now, but Z, normal distribution variable, is nothing but due date minus expected date upon standard deviation. 1.29 is due date, we don't know, minus expected date. Expected date is given to you as your normal project completion time, that is 38, upon standard deviation 6.04. So 1.29 into 6.04 is due date minus 38. Someone please help me with this multiplication. 1.29 into
7.7916.
7.7916 plus 38 is due date.
45.7916
is due date, which can be approximately written as 46 weeks. So there is 90% confidence that the project will be completed in time in 46 weeks. Fine, do we get this thing clear? Next, second part of the question, they are saying that there is a huge penalty for exceeding a deadline of 44 weeks. What is the probability of being penalized? Right? Penalty for exceeding 44 weeks. Right? There is a penalty for exceeding the project by 44 weeks. Now, my normal project completion time is 38 weeks. Let us first find out the probability of completing the project in 44 weeks. Right? First, let us find out the probability of completing the project in 44 weeks. For which I need to first find out Z. Z is due date minus expected date upon standard deviation. 44 weeks minus my normal project completion is 38 upon standard deviation 6.04. So this is going to be 44 minus 38. When you work this out,
0.9933.
44 minus 0.99. Right? Do we get this in here? Now, that means if I were to show you this with my bell curve, this is going to be my 38 weeks. This is going to be 44 weeks. This area I already know half the bell curve is 0.5. I want to find out this area, for which I can say that this area I have to look at 0.99 in the column. So if I look at 0.99 is 0.3389. So 0.3389. This point is Z, which was 0.99. So this area is 0.3389. So probability that the project is completed in 44 weeks is going to be 0.5 plus 0.3389. That's 0.8389. That's the probability that the project will be completed in 44 weeks. But I want to know what is the probability that it will not be completed in 44 weeks. Not be completed in 44 weeks. Probability that project not completed in 44 weeks is 1 minus project completed in 44 weeks, probability of 44 weeks. So this is 1 minus 0.8389. So this is 0.1611. That is the probability that the project will not be completed in 44 weeks. Now, if the project is not completed in 44 weeks, I am definitely getting penalized. So the probability that you will get penalized is 0.1611. That's the probability that you would be penalized. So the probability of being penalized is 0.1611. Right? Do we understand this? This finishes the sum. We'll stop this here for the day. Thank you very much.